Solve for x. Here I have 10 to the x equal to 3.91. Now I'm trying to solve for a variable that's an exponent. One logical thing to try is to make this base an exponential expression out of the number on the right, or make this number on the right, which is 3.91, and express it as an exponential expression with base 10. But that's not going to be possible because I can't express 10 in base 3 and I can't express 3 in base 10. And further than that, they don't have a common factor that we can potentially use as an exponential expression. Whenever that happens, I'm going to turn to this logarithmic approach. I'm going to take the logarithm of both sides, and I'm going to use base 10. So I'm going to take the log of 10x, 10 to the x, and then that's going to equal the logarithm of 3.91. Doing so, now I can use the property of logarithms, which tells me that whenever my argument is an exponential expression, I can move that exponent next to the logarithm. So now I'm going to get x log 10 equal to log of 3.91. Now log base 10, that's just going to be 1, so that's going to cancel out. So I get that x is equal to log 3.91. And if we put this in a calculator, this is going to simplify, or I should say this is going to approximate to about 0.59. I will use a similar approach on this next problem. Here I have to solve 5 raised to the x minus 2, and then that's going to equal 4 raised to the 2x plus 3. So I'm going to begin by taking the logarithm of both sides, and that's going to yield this new equation, log of 5 to the x minus 2 equal to the log of 4 to x plus 3. Now, using the property of logarithms, since I have an argument that's an exponential expression, I can move that exponent next to the logarithm. So now I'm going to get x minus 2 log base 10 of 5, and then that's going to equal 2x plus 3 multiplied with log base 10 of 4. Now it's at this point that I'm going to distribute the log. So here I have x log of 5 minus 2 log of 5, and then that's going to equal 2x log of 4 plus 3 log of 4. I'm going to move all x's to one side. So beginning with the logarithms, I'm going to move the negative x log 5 to the right side. So now I get negative 2 log 5. It's going to equal 2x log 4 minus x log 5 plus 3 log 4. And now I'm going to move the 3 log 4. Notice that this is the only one that doesn't have an x. So I'm going to move this one to the left hand side. So now I'm going to subtract 3 log of 4. Which is going to give me negative 2 log 5 minus 3 log 4. And then that's going to equal x 2 log 4 minus log 5. I factored the GCF right here. So 2x log 4 and x log 5, the GCF would be x. So I'm factoring out the x. That's going to result in 2 log 4 minus log 5. Now I'm going to divide both sides by 2 log 4 minus log 5. That's going to allow me to isolate x. Okay, so whatever I do to one side, I'm going to have to do it to the other. So on the left, I also divide it by 2 log 4 minus log 5. And on the right hand side, x gets isolated. So x equals negative 2 log 5 minus 3 log 4 all over 2 log 4 minus log 5. This would be the exact solution. And if you were to put this result on the calculator, you get an approximation of about negative 6.34.